So, what I've chosen to actually talk about is something a little more constructive, which is the context of the Yeti project, because we did touch the third rail of internet governance. We decided that we were going to tinker with the root zone. This was considered highly controversial, I would say, but I personally spent half of my time in the first 18 months of this project answering worried questions from people who were worried that perhaps we were trying to take over the role of IANA or do something else that would reshape the economics or the technology of DNS. We were not here to do any of the things they were worried about, but that does not relieve you of the need to answer those questions over and over. Next slide. So one of the things that we wanted to show with this is that the root zone is a concept, not an object. It is not a specific artifact that exists in one place at any given time that can somehow be stolen or taken. The root zone is a concept that relies on cooperation and also shared belief. And this is not unlike many other internet identifier systems. For example, if you get address space allocated to you by RIPE or APNIC or ARIN, there is no law that prohibits other people from trying to use the same address space. It's against the rules, but anyone who wants to break those rules could break those rules. And you might find that your address space was being used by more than one network, yours and somebody else's, and that neither one of you was going to get global coverage. Now, we don't see very much of that other than by accident or by criminal design from time to time. And so that is another example where it is our cooperation as a community that gives rise to the value of this system. And that distinction of the difference between an object and a concept and the need for cooperation turned out to be central to what we had to explain in order to get folks to understand that Yeti was not an alternative route. To be an alternative route, there have been several different entities across the decades who have said, we don't like the IANA system, this is our system, you should switch your DNS to us. These always fail, but they've created a rut in the mental landscape, and if you act the way we acted, you look like one of them. So let me explain what the different functions are. To be the editor, in this case, means to decide what goes in. There was a time before, let's say, .com, .net, and .org, where the DNS did not have very much in it, and somebody somewhere had to take the editorial function in hand and decide that those names would exist. I actually know the guy, and he was a program manager for DARPA at the time that this was happening. And there was no democracy, there was no representative system. He just had to start somewhere, so we started with that. Now we have a much more complex editorial function. The IETF is the actual creator of the namespace by virtue of having published an RFC document that describes how to access the namespace. So they never claimed copyright or ownership or anything like that. They just said, there is a specification called domain name service, and it works like this. And they then appointed another ISTAR organization called IANA, who had the task of just being the secretary and trying to remember what had been created and who it was supposed to point at. IANA still exists, although at the time this was all done, it was one man. He's not with us anymore. But the idea here was not that the IANA would decide for itself what went in and what went out. The IANA's job was to keep track of allocations and it would become other companies' jobs, other organizations would have the job of deciding how to create new resources. So in this case, IANA does not tell us what we can and cannot do. They tell us what form our organizations must take in order to be seen as representative. So again, if we use RIPE or APNIC, they are membership organizations. They have their own corporate boards. They have their own rules about transparency, about policy setting. And ICANN also has something very much like that. They have a separate board. They have rules. They have some transparency. And ultimately, IETF delegated to IANA the secretarial function of keeping track of what's in the namespace. And eventually, in 1998, when ICANN was formed, the job of coming up with policy for DNS went to ICANN. About the same time, ICANN also took over the IANA functions contract, once again as a purely secretarial function. So ICANN actually has two roles now. Three roles. One is to make sure that the community is able to set policy through a somewhat democratic representative way. Then they run the IANA to make sure that all of the community's decisions are recorded. And then they also effectively select the servers where the names will be served from. So I am part of the root name server operator community, and I have been since before ICANN existed. But ultimately, we all have our place now in a system that isn't a secret handshake. It is a system with a whole lot of politicians and a whole lot of money and everybody trying to gain influence. It is, in other words, almost as messy as real life. And most of us prefer the way things were before, except that before all of this happened, I couldn't make a living doing DNS, and now I can, so I guess it's good. But that's the editorial function. Yeti takes no role in the editorial function. Now you have the signing function, because in recent decades, we've added DNSSEC. So we now have the ability to attach a crypto authentic signature to every set of records. And the key that is used to sign those records is registered with the parent zone. And so if you follow it all the way back to the top, it turns out that having the key that signs the root zone gives you the power, whether you have it validly or not, or whether it's politically correct, it gives you, technically speaking, the power to affect what is in the root name zone, the root zone. And so the signing function is as important as the editorial function because it has that technical power. And so there's a great deal of transparency required of that. I think we were listening earlier today to a key signing ceremony because they have to periodically make a new key, because you should only use a key for a limited period of time before you give up on it and switch to a new one. ICANN is running all of that. But what we have now for the signing function is that IANA and ICANN have this editorial job where they will make a change, and then they will hand over a copy of the root zone that they intend to publish to VeriSign, who actually holds the current signing key and has the machinery necessary to generate a new set of signatures for this week's copy of the root zone. All of this is well documented. You don't have to try to remember anything I might say. If it was useful, you can simply Google any of this and you'll find out quite a bit about it. Here, Yeti took a role because we had to change some of the metadata in the zone that was covered by a key. And so we had to come up with our own key management system, which I thought was kind of fun, but it took a long time. I think we spent a year getting that right. And then it turned out that we didn't even need to do most of what we had done. But nevertheless, we did have to become a root zone signer because we had our own version of the root zone. One of our stated principles, and one which I have challenged the community to watch us to make sure that we follow, is that we will never amend the namespace itself. So, because again, if you have a signing role, then you, technically speaking, you have the ability to amend the namespace. So you might imagine, let's say, China and Japan are arguing over who owns some island out in the Taiwan Straits. And you could imagine that since we have somebody in our coordinators look from China and somebody else from Japan, you can imagine that somehow they may make an agreement to create a new top-level domain just for that island and sort of make a virtual country. If we did that, everyone in the world would know instantly that we have done it. So yes, we certainly have that power, but the control by which you can see that we do not use it is whatever we publish. We have never published any name that did not come from IANA, although we've talked about doing one.
Yeah, I will mention that.
Yeah. We needed to find out if there was a way to get the root name servers for Yeti named in the root zone itself so they would be signed. So that was one of our experiments. But it was clearly not intended to create a new TLD like .sex or .love where you could sell subdomains, which I think is what people are really worried that we might do. We also learned, as part of the science fair that was Yeti in the first years, that we didn't have to re-sign IANA's names at all. You can have more than one root key. They all coexist because each one has a unique key ID. And you can end up signing most of the zone with one key and part of the zone with another key. So we didn't actually need to take over the signing of IANA's data. And that was Davey's contribution, one of Davey's contributions. Finally, there is a publication function. In other words, what are the servers? Who operates them? Where are they? And this turns out to matter least of all. Recently, there was an incredibly ill-considered RFC, which is 7706, which describes a method of having each recursive name server contain its own copy of the root zone. Now, I'm not going to get into the reasons why I think that was ill-considered. I'll simply say is that meant that the publication function of the root was for those users, the people who followed the advice of our RFC 7706, became irrelevant. It no longer mattered to those people who operated the root name servers. They essentially operated one for themselves in the privacy of their own network. Now that sort of thing has been happening for a long time. In fact, FreeBSD famously set up their name service on all of the FreeBSD systems that were installed. From the if you set up a new FreeBSD system, it would do this. It would actually make a local copy of the root zone. And this was quite controversial, and it was taken out. But I think now that there's an RFC that describes it, which is at least 10, maybe 12 years later than when FreeBSD did this, I think maybe FreeBSD will go back to doing it again. Our devices, holding up two cell phones here, are now so powerful that every one of them could operate its own root name server if there was a reason to do so. I think there is really not a reason to do so. But the point is, no one can stop anyone else from doing this. So anyone who thinks they have a reason can do it. But that publication function is certainly another thing I forgot to list. Yeti as one of the parties here, because in order to serve a modified version of the root zone signed with our keys, we needed our own set of servers. And so I operated one for the first 3 years and then stopped. One of our goals for science there was to find out what would happen with really, really large responses. So we wanted to make sure that there were 25 different name servers They only had quad A records. They didn't have A records, so there was no V4 connectivity. Several of them had more than one IPv6 quad A record, because that's something no other root server had ever done. And we really just wanted to find out the borders of sanity for this system, and what could we do that would not break? And when it broke, how did it break? And what light did that shine on how the system itself was then going to operate? So yes, Yeti had to take a role there, although I forgot to list it in the bullet.
Do you mind I will add it later in the slides when I distribute?
So once you see the root zone as a concept, not as an object, and you see that the concept involves so many different roles, then and only then can you sort of let your heart rate return to normal and see someone tinkering with some of this without fearing that they are doing the alternative root business plan. So I think one of the outcomes of Yeti has been this, although this wasn't our stated reason, this was just something we had to establish in order to answer the questions that we got. Nevertheless, we have now established this pretty well. I'm not sure 7706 could have been passed in the IETF working group if Yeti hadn't been there first to say, you know, who publishes it doesn't matter. It's what the data is. That's what matters. You have to be able to separate the question of who's publishing it from who edits it and who signs it. Next slide. So here, I intend to demonstrate amendments to namespaces. And this is as old as the DNS itself. In other words, in 1986, when 4.3 BSD came out, and then later in the year, the bind kit came out, and people started being able to use DNS in enterprise networks instead of using an etc host file that they would move around with the FTP command. The very first day that that was possible, somebody amended the namespace, because they already had a bunch of local names for things that were not reachable by the internet, and they wanted to make sure that they could reach all of their local names through DNS without having to register those names in the global DNS. Sometimes we did this for security. There might be a firewall where a few hosts could see both inside and outside, but most people inside couldn't see outside, and most people outside couldn't see inside. Sometimes it was done for sort of secrecy, like you want to be able to have a bunch of names that will give away the company's strategy, because they will, you know, you want DNS names that you're using for unannounced product development, and you don't necessarily want those names to be in the hands of your competitors, so you don't put them in the global DNS. It was also possible that you had names that you were pretty comfortable with. In this case, I've assumed that Apple was doing this. Who knows if they were just the example that came to my mind. And if you were inside of Apple's networks, you might have wanted to be able to look up names ending in .apple. By the way, Apple has since become a generic top-level domain. So maybe that's a bad example here. Nevertheless, this has been happening for as long as the DNS has existed. And it is an alternate namespace, but it's a very particular kind of alternate namespace, which is enterprise class. They are not, the people who were doing this in 1987 were not hoping to be able to create a namespace that would become wildly popular and would replace the IANA's namespace. They were simply solving an operational problem that they had. A lot of them got burned. Next slide. Which is where they would set up some kind of a joint venture with another company who was doing the same thing. Or one of them would buy the other, and all of a sudden you had to merge the networks, but they were each using local amendments to the namespace. Right? It's when this happens to you as a sysadmin that you begin to really realize how much benefit you get from a single, unified, coherent namespace, because you don't have to rename anything when you merge networks, because the names are all universal, or sometimes we say global. And what happened instead for the companies who faced this problem is that their IT departments got together and said, okay, we're both using whatever, network 10, and we have a few collisions there, so if we're, we've got to renumber the things that are colliding. But we're also both amending the DNS namespace, so we've each got to add a pointer in our own private root pointing to the other guy's amendments, and then that kind of worked. You were able to get through an acquisition or a joint venture by just having a bunch of static configuration elements. And again, I want to point out, this has been going on as long as the DNS has existed. Yeti didn't invent it. It is not the same as an alternate root in that they aren't hoping to sell names in this new namespace. They are simply setting up the names that they need in order to access their own network resources. And here we benefited a lot from the move to the so-called cloud, where instead of having a data center full of equipment behind a firewall so you know where the perimeter is, you've got bits of your equipment all over the world, and there are sometimes virtual machines inside of various providers like Azure or Amazon, and it gets to be so difficult to use private names for those when they're crossing cloud providers, and some of them are in your own data centers and some are not. But it's actually much cheaper now to just keep all of your names in the global namespace and make sure you never put anything into those names that would give away company secrets. So that we have gradually come to the point where it becomes a rationally selfish act to make sure that you're not doing what is on the screen right now. Next slide. So, given that we have been able to take what was thought to be an artifact, the root zone or the DNS namespace, and decompose it into a concept having a whole lot of antecedents, are there any invariants left? Is there anything that we believed coming into all of this that we still believe and that has not been overtaken by events? I would very much like it to be, as Rod Beckstrom famously said, one world, one network, one namespace. And we will keep saying that because it's a good vision. But since it has been locally amended, I have a bunch of names ending in .com, and I'll bet some of you do too. Sometimes my local amendments end up conflicting with new global assignments. It really bothers me that there's going to be, or is already, a .home out there in the world that I will not be able to access because I treat those names as local. All right, so what we have is one network and one namespace, except as locally amended. So if you go back one slide, what you have is a network that has some local resources, that has some local names, but no one outside your network will ever care because those names refer to assets they can't reach, like they're in your version of .10, which they can't route to or something like that. It doesn't really matter politically or economically that you have amended the namespace, but nevertheless, every network gets a chance to decide what namespace it is going to have. Skip 2. There we go. So this system is under pressure. Very few of us are left from the days before there was a lot of money to be made in DNS. I can tell you things were quieter then. You didn't have people coming in saying, I want to sell .sex names and I'm going to sue you if you don't give me the delegation. That all came later, and it was a little bit more fun when it was just a bunch of technologists building and using this. But again, I wish to point out that I am grateful that I can make a living doing this, because otherwise it would be my hobby. So the BRICS countries, Brazil, Russia, India, China, South Africa, pretty much all feel left out. You talk to a diplomat from one of those countries, they will say, America kept all the address space for itself, and we don't have any root name server operators that are incorporated in this country, operated by citizens of this country. And so we feel that we don't have a seat at the table. We're not as important, or we're being kept away from the important part of governance. Now, I think that's all crap, but it's what people believe. And so that is one of the pressures on the system. This is why Davey for BII probably gets the question much more often than I hear it, which is Yeti the way that China intends to get its own root name servers? I don't think so. I think if China wanted to get its own root name server, they would probably find some other way to do it than a bunch of network science. Nevertheless, that's a question that comes often. A lot of countries are now filtering out the DNS they don't like. And I guess that's inevitable. India just announced that they will set up a national recursive name service. And I don't know exactly what's going on, but I assume it's got something to do with people not being able to reach Pakistan or something like that. It doesn't matter what their reasons are. The fact is they don't want global, unique, universal name service to work in India. They don't have it in the United Kingdom either. ISPs there are required by law to filter out things that the government tells them to filter out. And the law is written in terms of online child abuse materials, and you might be able to imagine why it feels good to say I'm not going to resolve things that could result in children being harmed. Nevertheless, it never ends there, because once you have a mechanism that lets the government determine what the people can't see, then other things, I mean, what about people for the ethical treatment of animals, right? Are they going to be concerned about websites involving meat, and what kind of political power will they have? Nevertheless, that is a pressure against the ubiquity of DNS and the universal coherence of it. I mentioned there have been plenty of companies who set up an alternative namespace because they wanted to profit by it. And I remember, I think it was .xxx, which is means pornography, at least in the United States, used to work in one place in the world, at the Schiphol Airport in Amsterdam. Got on their Wi-Fi, you could look up .xxx names. And the company that did that for them, or that was selling the names, had told the Schiphol Airport IT department, this is fine, there's nothing controversial about it, it'll all be just fine, which was a lie. It turned out that eventually there was another .xxx that got created, but it was for a different party. And this party, because they had Schiphol Airport as one of their joint venture partners, felt that they had standing to sue the new guys. And it's, that's the kind of crazy stuff that you get if what you want to do is profit by expanding this. It turns out it's much easier to essentially take over the ICANN board of directors and capture your regulator, get them to do what you want, than it is to go create alternative infrastructure and then claim that that gives you standing. So what we're seeing at this instant is a whole bunch of energy expended to bypass the local recursive name servers that would otherwise serve your network. Now, I don't permit this from my day job or from my home network because I want to make very sure that every answer that is seen by any user or application inside my perimeter has been witnessed by me, at least, and possibly filtered by me if it's a policy violation. My network, it's my policy. If anybody doesn't like my policy, they don't have to use my Wi-Fi. Or if they don't like my policy, they don't have to work at my company, right? You can always vote with your feet and go somewhere that isn't going to control your DNS. So I'm not keeping them from having uncontrolled DNS. I'm keeping them from having uncontrolled DNS at my house. That's my right. But some don't see it that way. So DNS over HTTP was RFC was published recently, and it says in its abstract that one of its goals, one of the stated goals of this protocol, is to prevent on-path interference with DNS operations. I got to tell you that on-path interference with DNS operations is what I do. That's, in fact, a third of the parental controls software or hardware in the world does that. The reason it works is that it is able to be an on-path attacker against DNS content that the network operator, the parents in this case, consider to be malicious. Nevertheless, the IETF has rubber stamped this thing, and we're now starting to see deployment. I believe somewhere in my Android phone there is a button I could press that would get it to use this. Note that they won't say on the user interface on my phone, this is controversial. They don't even say it's DNS over HTTP. They just say, do you want DNS privacy? Who among us wouldn't want DNS privacy? So I saw a report, which I'll be blogging about probably from here this weekend, where one of our academic partners has used our data to study things like DNS tunnels. And they have found that there's really a huge amount of traffic that is carried by DNS in the format of DNS, but it didn't come from any zone file, and it's not going to any application who's trying to look something up. They're carrying sometimes an entire VPN in DNS responses and DNS query names. I don't want that happening at my house. Davey lives in a country where the use of a VPN could cause you to go to jail. I don't like that. I don't visit China as often as I would if they didn't have that kind of restriction, because I got to get work done. I've also got to be able to reach the Golang documentation archives, but that's a different matter. But the point is, it's not really up to the IETF to tell me what DNS content I have to accept, or for the IETF to tell China what DNS content they have to accept. It's their network, it's their rules. That's been my view. But there are, as you see, competing views. Now, there are a lot of folks out there who want full recourse. So that if somebody takes an action online using some identifier, like an IP address, or domain name, or an ASN, that there will be a trail of breadcrumbs leading through the forest back to where they live, so that you can go to them and say, hey, you stole from me, I'm suing you, or hey, you stole from him, I'm arresting you. That would be called recourse. Recourse just means there's something you can do about what happened. And then there are a bunch of other people who want zero recourse. They use whois as an example. Often you'll hear somebody from civil society say that they, if a political dissident somewhere can be found through whois, then there will be no dissent. And what I'm trying to point out is that if you thought whois privacy was going to keep the government from finding out where you live and kicking your door in, then you are foolish and confused, because they don't need whois to find out who you are and what you said. And if you really want to be a dissident, you may have to go abroad, or you may need to find some VPN or Tor or something that your government can't detect. But you're certainly not going to be a better dissident because there's no whois, any more than you will be a better dissident because you have DNS privacy. That is an excuse that gets trotted out because a lot of people in the world think that speech should be free, political speech should be possible, and they want the internet to be the mechanism by which the world becomes that. I don't think that the internet is going to be the mechanism by which the world becomes that. The world becomes that, it will be because it wants to, not because we simply made it possible, and that somehow, I mean, I'm trying to imagine, again, pointing to Davey, the Cloudflare company has a permit, has a license to operate within China. And that is necessary for a Western company doing business of this kind. And they operate 1.1.1.1, which is a name server. It's actually using some APNIC address space. And I'm trying to imagine one of two things. Either the government of China says, yeah, 1.1 is okay. And we're going to block all kinds of DNS in the Great Firewall, but if somebody inside of our country knows to use 1.1, go ahead and give them the correct answer. I'm trying to imagine the Chinese government taking that position, and I'm struggling to imagine that. I'm also trying to imagine the Chinese government saying, oh, okay, now that you've got DNS over HTTPS, and we won't be able to tell what is or is not a DNS transaction as it goes through the Great Firewall, we're just going to stop blocking DNS. Clearly, the world has moved on, and it's no longer possible for us to execute our political machinations. I'm struggling to imagine that also. So the idea that these technologies are going to force existing meat space law and custom to change is crazy talk. But the pressures are all there. A takedown is very hard. Often it's because let's say you've got enough recourse somehow, either who has worked or you've used some other method to find out who is the actual person, the actor, the company, the service that caused the phishing attack or the DDoS attack or did whatever it is that you're trying to get recourse against. It may be that you can get complete information and find out exactly who hosts them and exactly what their name is, but they will be in some country that you don't have a treaty with. So you can't get law enforcement to cooperate. And it may be that you will talk to the ISP and they will say something useless. They might say they're not breaking the law here, they may be breaking the law where you are, but it's not a problem for us. They might say, yeah, they have a very strong contract, we would owe them a lot of money if we disconnected them, so you're just going to have to deal with the abuse. They might say, oh yeah, we took care of that. Whatever it is that they say will often be a lie, and it's simply intended to get you out of their inbox and off the phone. We even found in one case a company called Atrivo, which was operating a data center in San Francisco, was owned by all of the customers that they claimed that they were not able to disconnect. So it was not until the FBI came with the trucks and emptied the data center that finally went offline. So your incentives when you're trying to get recourse, you're trying to prevent future abuse against you by some party, are not necessarily aligned with the incentives of their own supply chain. Maybe a lot of people profiting from the harm that is coming to you. And that also puts pressure on the DNS. And if you want to look up RPZ, response policy zones or DNS firewalls, you'll see what we're doing about that, making it possible to do takedown in the middle because you can't seem to get takedown at the far end, so you got to get it somewhere else. All of this is putting continuous and rising pressure against the uniformity of DNS. There's almost no one left in the world who wants DNS to work perfectly for all names and for all end users, all applications, and all services. In other words, everybody in the world has taken a side that ultimately is against that for some particular reason of their own. I expect that trend to continue. One of the things that I was happy about with the Yeti project is that we were able to highlight some of these stresses. In particular, highlight that it doesn't matter who serves the content or how it's served, only that the content be determined according to ICANN rules, and that the namespace be the same no matter how you got your access to it. That turned out to be really important. We did not think that was going to be important because it seemed pretty obvious to us. But then we went off to do this and discovered from the questions we got that no, everybody's terrified about alternate route services. Wolfgang Kleinwachter and Vince Cerf published something in the World Economic Forum about Yeti because it, quacked like a goose and it walked like a goose, so it must be a goose. In other words, they said it looks like an alternate route name service to us. And I kind of enjoyed having an opportunity to explain, no, it isn't, and here's why. Although it's always terrifying to disagree with it. All right, that's more time than I said I would take. Thank you for letting me have it. Should we have any discussion before we move on to Davey's version of some of these events? By the way, Japan loves you, but they are trying to kill you, and there are chocolate-covered things back there that you should eat so that you will die. That's what I'm about to do.
Okay, thank you. Thank you, Paul. Okay. Yeah, we can, if you don't have instant questions or topic question to Paul, we can move this thoroughly. We have time in the end of this day today. Okay, I will give a review. So Kevin, you can help me on this. You can open one. No. I think here. You can open it. And you can share it. You can play it. Okay? Okay. You can grab some coffee. Okay. Almost every workshop, since the time we found the project, we have previous two workshops, and this is the third one. And every time we'll give a review because I coordinate all these details of the project. So I'm the one to summarize most of the work and what we're going to do and what challenges we have. So I will do it again and as a review so that can bring us to the one same page about this project. And also collected some proposed future agenda for our future work. So I can brief you, and then we may take this opportunity to discuss whether it was to do or not. Okay, I will want to start with from the beginning. 4 years ago, exactly the Y Camp in 2015. We will have the Y Camp spring camp next week. Okay? So I repeated this from the beginning. After that meeting, we have an on-conference in Y Camp. In the on-conference, you can propose any topic and ideas or for the theme of the conference. You can have a small gather of people. In that camp, just after a workshop hosted by Vixie in the end of 2014. In 2014, November 2014, I think, there is a workshop on the root stuff. At that time, there's two competing draft. One is the formal draft of the RC 1706, and another one is proposed by Civic and about universal endcast. I'm not going to go detail the two and the discussion there. I just want to we revealed that after that, because at that time there's a hot topic, how to pervasively distribute the user. So there are two, and also BI also participate in that workshop and bring some proposals as one of them. And after that, we participate to the Wild Camp in 2015, and so we some kind of thinking that why not to build a test bed to try different approach, a different kind of distribution method for the root zone. So that's the beginning of the Yeti project. Next. So at that conference, we make a decision that we can kick off to start from the technical proposal. So we set up a Google Doc and we exchange ideas every 1 or 2 weeks. So we finally finished it months after. And then we have a concept to do this, a comprehensive concept of doing this exercise. We first identify the problem base of the Yeti project before it founded. At that time, we have some motivation or some background that for some regions or some autonomous systems, they want to reduce the external dependency and also want to reduce the surveillance risk if they send all the queries, DNS queries to the root. The root is operated by a foreign company, entity, etc. Because at that time, the DNS privacy is proposed, raised as an important topic at that time. Okay, so another part of the problem space is related to next slide. It's related to the technical challenges 4 years ago. One is that IPv6 only DNS or root can survive, and at that time, before I can roll the key, so it's ready for case rollover or not. So we have a goal to want to roll the key before I can do the large scale real operation system. So we also come up with other challenges, for example, reliability issues and etc. Next slide. And we distribute the flyers about the Yeti DNS project in the ICANN meeting in 2015. And we outreach many parties and stakeholders. So that's the two previous workshop. We did it. We did it. The first one in Yokohama, in the ITF in Yokohama in 2015. And I think at that time we are in the process of setting this system up. And we also had some challenges during that time. We almost take 1 year to make the system ready and stable because we adopt different architectures. I will introduce later. And we said we hosted another one in the next year after the Yokohama. And in that workshop, we demonstrate some results we have in some experiment we've done. So there is one very quick review of the deliverables we achieved, we have done. So we can see that we firstly, and some engineering work, we built a global live IPv6 only Yeti DNS testbed with 25 root servers. At that time, we want to scale the system beyond 13 to see whether the system can work or not. To support the system, we build we have our own website, our system, main list, and monitoring configurations. We done some experiments, including multiple signers to roll the key and operations under Vixie only environment. We put all our deliverables and some technical report of each activities on the website, and to make this public and transparency as possible. And last year we published one IETF informational draft about how the system, what's the intention of the Yeti DNS and how we build this system, what's the experience we gain. And we also deliver some draft. It's not finally reached consensus from the community, but we also deliver some draft to specific items. There are also some software and the tools we developed during the past years. And also, it's not mentioned in the RC or any public reports, but I think Yeti demonstrates an alternative model of root zone distribution. And I think Paul also recognizes and categorizes it as a model of root zone distributions compared to RC 7706. I will discuss that. I will discuss this part in the end of for more thought. I'm not going to go through the whole document of the Yeti RC, and I just want to just give a very brief introduction of the structure. We proposed the study area of Yeti DNS. At that time, when we set up this, we introduced how the testbed structured, how this testbed built, and the brief infrastructure structure, so that people can build by their own self if they want to build a Turkey testbed, root testbed. Actually, this part introduced the exact technology and know-how. If a network operator wants to build their own root system instead of a local copy of the root. So that's why I think Yeti model provide an alternative way of distribution root zone. And also we produce some, deliver some operational experience with the Yeti testbed. Some operation, IPv6 operation, root zone generation, distribution, and DNS case rollover. You can go more details to read this document. And we finally conclude, give a conclusion of what we did and what we are maybe going to do in the future as a future study. Next slide. Okay, return to the review of the principles Yeti in the past year kept in mind is that we keep boundary of what we namespace. It's mentioned by Paul in his previous slides. That's there is one slogan proposed by Paul at that time that one namespace, many circles. That defines Yeti's function in the beginning. That we have different we may create a different circle, different access to the one namespace resolution paths or root systems, but there's one namespace we need to cap. We intentionally not amending the IANA namespace by reject some experiment ideas. At that time, one active participant, also the sponsor of Yeti, by donate one name service, Postmail, suggests that Stephen Postmail suggests that using DNAME in the root for the delegation of special use TLD. At that time, he proposed a draft to introduce DNAMs. That may introduce some modification of the IANA root zone. So at that time, we under some pressure from the community, so we keep the boundary that we are not going to amend the IANA namespace, even reject some experiment ideas. And to keep the binary, we also try to, the Yeti Eurozone small different, still different from IANA. We amend a little bit with corresponding metadata for the testbed, for example, the apex record, including the DNS record and the NS record set. So we try to minimize the difference, use different technology to transform IANA Eurozone to Yeti Eurozone. One experiment Paul mentioned, it's called the PINS experiment. PINS experiment include all IANA signatures by IANA CSK. So we only need to change it as less as possible, keep the minimal change only on the apex record. Okay, next slide. And I want to take this chance to propose that the two notable issues, and that also the issues or direction problem we will continue to tackle in the future. Two notable issues. One is about the IPv6 fragmentation impact or large DNS response. That's the one issues. It happens. It's proposed. It's discussed in the whole IETF in the IETF community before, and we keep a close eye on the issues in the Yeti testbed because we run on IPv6 only. If IPv6 cannot work or have some deadly impact, it will never go to work for the future IPv6 only internet. So we dedicate some non-trivial efforts on these issues. Next slide. And in the Yeti RFC, we identify this because there is some work, some measurement work to report that the IPv6 fragments, not only the fragment, but also the IPv6 packet with the extension header were dropped by the middle box largely. There are some RFC 1780, 72 give some numbers over 1/3 of the packets in different scenarios. And the APNIC also do a study more than 1/3 to identify this problem. Especially, in one word, the combination of the large DNS response and the UDP, DNS over UDP as a major transport protocol, and also the network that filtering the IPv6 fragments or the extension header. The combination of these factors produce this problem. It's not the DNS stand-alone issues, but it's a combination. And we also observe that when this is a timeline, and we observe when we have large response, more than 1975 bytes, because we include these three the keys from 3DN, and we observe around 7% of venues. We use Atlas props to calculate and collect the data, and we can see the difference with how the size of the packet impacts the venues. So next slide. Yeah, as far as I know, the countermeasures of this issue, there are mainly two approaches. One is to not rely only on the UDP as a transport, but fall back to TCP. DNS has an inherent mechanism to fall back to TCP later or sooner. It can be done on the client to set DNS 0 buffer size into a certain number from the beginning of the query. And also we can done something in the server for authority server to set the maximum UDP response size smaller. And I also proposed one fix on the server side that we can go back to TCP more sooner. Next slide. Yeah, that's the one example tries. We add a function after the DNS truncation loop. If the pocket is very large, then we will generate another additional truncated response. In case the truncated response of the large DNS pocket dropped in the middle, the reserver can still receive a smaller one. So that can help them to fall back TCP more sooner. It got a pretty pushback from the DNS working group. They may think it's a too narrow question, and also introduce some complexity and some noise of ICMP. But it can deploy on the server and without modification of reserver. And it also reserve some property to let the reserver to receive large response, fair chance of large response, truncated response without fallback to TCP. That's the property of ATR, because only around 1/3 of the large pocket truncated large, not truncated, it's fragmented large response. Only 1/3 of them will be dropped. It's supposed to be dropped, but still a large chance of them will be received by the reserver. So it's not necessary to fall back every time for each case. That's the property ATR provides. Okay, next slide. There is another approach to counter this issue, to reduce the size of DNS response. There are already some plenty of discussions in the community about the problem brought by the DNSSEC in terms of the large response, because the largely deployed the DNSSEC algorithm use the RSA to generate keys and signature, but RSA generate fair large keys and signatures that increase the size of response when you set your new bit in your query, and you will get even more than 1,500 bytes of the response. The notable case is the .org. The .org return more than 1,300 response. I guess they add some standby keys in the response. So there is some suggestions proposed before using elliptical curve cryptical to shrink the size of response, because the ECC has much smaller keys and the signature is equivalent of better key splits. So if we going to use ECC instead of RSA, the algorithm rollover is a very key vital part to translate from one algorithm to another for the purpose of reduced response. Okay, some facts about ECC, if you are the first time to know it. ECC has much smaller keys and signatures. I just compare them. If you have a 248-bit RSA, you finally generate 251 bytes R data and 160 bytes DNSK R data. Usually, in the response of DNSK, you may include it more than one, right? In any case, in most case, in extreme case, include 5 keys, so it will multiply 5, and also it will add this as a signature. But in ECDSA, one kind of the ECC, P 256. We only end up with 59 bit by RC data and 64 by DSK data. So it's dramatically reduced the size of the response. And from the security aspect, the ECC with the 256 bit group equivalent to the strength of the RC 3072 bit. So it's a desirable property that people, technical people, would want to pursue. And they are all standardized and also implemented in the most popular DNS software. And there are some analyzed by subnet. The seeker curve is the original one with RSA without change. There are a fair chance of them beyond the IPv6 minimum MTU, 1280 bytes here. And there are a chance maybe 2.2%, maybe 2% or less than 1%. Will be around 1,500 bytes. So that will introduce the fragmentation issues. But with ECDSA 256, you will get this curve here. That's where most of this is less than 100, less than the IPv6 minimum MTU. And if you adopt combined signing key, the CSK, that means you don't necessarily to use CSK and KSK for different role for two set of keys. You can use only one pair of key to sign the zone and also as a transfer. And then this curve is here. It's less than 500 top. So it will return. It is that bring classical 1512 by DNS back to scope. I think this picture gives some evidence motivations why ECC is it's the direction for the DNS to avoid the IPv6 fragmentation issue. Next slide. Okay, that's one of the two notable issues IPv6 because we continue to transit to IPv6 to a full functional and IAB also encourage people to try the IPv6 only practice. So the second one is the redundancy model of Yeti multiple signers. Next slide. Okay, in the beginning of Yeti, we have the idea to introduce redundancy and avoid single point of filling. In the aspect of the signer, we introduce multiple signer, not only one signer. DM, we call it DM because it's an M for Verizon's role as a root zone and a root zone maintainer. Each signer signs the zone independently, publish the root zone and notify all receivers. Actually, we have 3 DM, 3 coordinator founders of Yeti take the role. We generate the root zone. We pull the root zone from INR or from the F roots. Then we sign independently. We use our own key, but share one unique KSK. That's our practice. But in the beginning, we proposed 3 versions of design: single ZSK and single ZSK mode. It's already done in the beginning, and single KSK and multiple ZSK mode. It's also done later, and currently we maintain this as current Yeti practice. And we also proposed if we can introduce multiple KSK and multiple ZSK model. It's not yet implemented, but it's just listed in our initial designs. I will talk this later in the afternoon. Some proposed back to 2006, 2003. Some people proposed to introduce multiple KSK. There are some formal discussion. I need to save more time. Okay. At the beginning of the Yeti, we describe the architecture of the multi-VM like this way. We're different from next slide. Right now, the IANA is already replaced. Their IANA generates the namespace and has authority to sign the key, use the KSK. And the word design as a DM to sign the distributed root zone. That's the model in the beginning of Yeti. And right now, Yeti implement this kind of. We honor the IANA namespace, and IANA also has their own KSK. We sign the distributed root zone file, and each DM will sign like the word design sign it. And actually, we use part of the IANA signing authority to sign the DSK asset, and we distribute to different group. It potentially can distribute different group of root servers, but actually we have one group with 25 root servers. It's technically possible that each DM can work independently and distribute a different set of root servers. That model will cover this case as a subcase, a subtree. So it's possible that I once proposed and that IANA can have one IANA generate the root namespace and different DM. The signer can generate different version of root zone to serve different group of server in different areas. For example, the regional areas. Or different countries. That's the possible extension of Yeti model. Next slide. We also observe some operational issues because most of the protocol, like the zone transfer and the notify, is not designed particularly for the multiple VM. So we notice some latencies, delays, the root zone distribution. Part of from the errors of the software, it's the bounding, band implementation, and some of the contribute to the mismatch of the zone transfer with multiple VM. Next slide. And we also have some issues. We observed multiple signers. In the pins experiment, we experienced some, that's the pin introduction, right? Okay, next slide, I already did with that. Okay, in the pins experiment, we happenly found an accident that one DM in BI failed to sign the zone. So we published unsigned the zone and distributed them without check. So that's introduced. That give us a thought that more redundancy does not equal to more resilience. If one DM failed, it will any one from the three has any failure will introduce risk to the system. So that current model not cover this case. Maybe we need to design more fault tolerant with checks, with checkings before we publish something. Next slide. Okay, that's a desirable fault tolerant root zone signing and distribution. I will talk this more detailed in the afternoon. The idea is to introduce a checking and redundancy mechanism provided fault tolerant property. Maybe we can increase more than 3 into this process and sign distribute the root zone in a distributed way without the risk that in the current multi-DM model has. We may introduce kind of MN signing. I will introduce this part later. Center close to sign the root zone to keep and also keep the asset validation process in the client interface. And we would like to achieve no or less centralized role in the process to fit in the governance context, because the 3DM, current 3DM model in the Yeti practice, we still have a unique position for each DM. So when we want to, we have some discussions how to implement the Yeti model to some real production work. And the one question is that who are elected as one DM. So it's it's a governance issue, but it's reflects the technical drawback behind it. So the idea design that we can it's idea to get rid of the special role in the system and to make them as equal as possible. Some proposals I reviewed that still involve one dealer in the beginning to distribute the key or distribute some to initialize the system, and the dealer will withdraw during the whole process. That's also ideal process. We are not we are not decentralized totally, but it's remove how to say to it's only rely on a dealer in the beginning. Okay, next slide. Okay, that's the one high-level structure I joined to compare. We already talked about this picture, right? And there is a proposed model to decentralize them to make more DM role to form a network. This network can sign the distributed root zone file jointly and corporately. And any of them, any failures of one a small group of DM not produce errors that break down whole system. So that's the main difference or main in the proposed model. Okay, next slide. We will come back later. Okay. As to the lesson we learned, I think in the beginning we imagined that our system can expand in numbers. For example, there are 13, maybe we can extend to 25 or more. But we are restricted by the limit, the packet size, the material issues. So I think it's continue to be a concern to increasing the number of root server to a large number by increasing the larger response priming query. That's not a good direction. And we add more DMs or root servers without proper services guarantee and consistent check may increase risk of instability. That's the utility. But we do have these issues when we practice this. And then we also have some lessons to coordinate the project and management project. I think periodically face-to-face meeting is necessary and reporting necessary. The network in different area in China, Japan, US, we have different time zone. We have the non-consistent network conditions, so that make the online call and meeting not easy for us. So periodically face-to-face meeting during the ITF or other international conference meeting, or like this workshop is very important. And the experiment should be carefully designed. In the beginning, we have some intuitive goals, and we just implement this and to see how it works. We lack of the careful designs and analyze CDES to demonstrate capacity fully. So that's the lesson we learn for our future experiments. Okay, there are drafts as in 2009 in the future. One is that we are going to we propose that in the next meeting, maybe half a year ago, we decide to design and implement algorithm role from the SA to ECDSA. We have already done some work, and we will show that in the afternoon. And we will prepare the recharge the Yeti DNS project. Because after 4 years of derivation, the hot attention of the problem may change after 4 years in the community and in the project itself. So we need to recharter the Yeti project and list the potential target we are going to do next. So we're going to we're already connected potential research agenda and maybe a new technical proposal for Yeti phase 2 to be drafted. And when we have the goal and the missions for the next phase, then the website of the Yeti will be published. That's the physical plan of Yeti in the 2019. And future, we have a list of work to do. Thanks. Okay. We have some list of work, and I put this in the repo, my repo, GitHub repo, and we can come back later in the afternoon. I think we are close to the time for lunch. So we will come back later, maybe in the opening part, open discussion part. Next slide. Okay, that's all, and that's my report on behalf of the project to outline what we have done and experience, lessons, and the 2 issues that continue doing in the future. Okay. Any questions? Jackie, you are the first time to.
I'm not quite familiar with history, but what I want to know is there any plan for real employment of Yeti results in the DNS system?
Good question. Actually, Yeti project has the position of the research aspect.
Yeah.
And any people interested on this, see this is a material, it's okay to implement in the MM. It's okay. And we're going to do in the future slides, next previous slides. We have a list of future agenda. You can see we will continue to tackle adverse fragmentation issues. We will design the distributed tolerant routes, assigning and distribution. That too are a match to the issues I mentioned before. And also we will do another to tackle the data issues, locally cached, warming cache issues. I think Paul may have more comments on this in the afternoon. We were talking about this because there are heated discussion compared to FC 7706. Yeti is a kind of, actually it can serve as a kind of local cache, local services for any zone, actually, because root server has the entrance, it can serve any slave zone in the root instead of loopback. If you are familiar with FC 7706, you can see the competitive, and also software and tools are deliverable for the future. You can see all these are not done before in the past. If you want to try in some areas or some, it's free. It's an open project. It's an open source.
And how about the attitude from other DNS road operator?
Sorry, what's the
attitude from?
Attitude.
Yeah.
Kelson and Paul are 2 of the current root server operators.
I'm talking the root and Yeti. So different ends, not mixed together.
Okay, we can have more questions and answers and discussions in the afternoon. So we will leave some time for lunch before the student and workers to occupy all the seats.
Yeah, all of the class has been gone this particular school year. Most of the students do not come to the university, and also it's thanks to the Saturday, so competition on the lunch place is very weak. But I strongly suggest you to go to the destination before noon.
Okay.
And this particular room is secure because I'm leaving while you are having lunch. So please take your variables, wallet, transport with you, but you may be to the other